So, what inspires me most about the work I do? Well, when I started out in life, I was a physicist, and we used a lot of computer programs in physics, and then I became an acoustician, which is essentially a kind of architectural designer, and all the time we're using these computer programs, and a lot of people cared about the front end and how it looked like, and mostly what I cared about was how everything worked behind the scenes. And particularly when I started using the cloud, and when I did my computer science degree, it was a lot of people wanted to make fancy web apps. I cared about what was going on behind it. How was this system working? And when we started doing this CDT, we started learning about cloud computing. The big questions and the big advantage to the cloud is it can scale out, it can adapt, it can do things that are very intelligent, very clever to kind of cope with extra demand, and everything will run brilliantly and we'll never have any delays. The big thing that I then realized once I started looking into the details was that there's not really a lot of intelligence behind that. It's a lot of very simple rules, load balancing and stuff, and that actually there's a great wealth of scope for improving things because these rules are very simple. So when my PhD supervisor suggested doing a research project that would take a slightly more kind of mathematical approach, slightly more intelligent approach to making these scaling decisions, that was really exciting to me, because this was creating the intelligence that I thought was always there, but now I'd get to have a part in that. I'd get to be a part of creating a more intelligent way of a clever back-end system. So the inspiring part for me is building those things, is trying to push the boundaries a little more to get a slightly more joined up system.